We're going to talk about what a cyclic alkene is, what it looks like, and we're also going to talk about how to name cyclic alkenes. All right, so these structures below have double bonds, so they're alkenes, and they're also cyclic, so we would call these cyclic alkenes. When you're naming these, your carbon-carbon double bond is going to get positions 1 and 2 no matter what. You always give them 1 and 2. Because they always get positions 1 and 2, you do not have to indicate their number when you're naming them. They always get 1 and 2. Everybody knows that, therefore you don't have to name it. When you have branches coming off, you're going to have to number those branches and you're going to name them just as before. So you're going to name them in alphabetical order, giving them the lowest carbon possible after you number the double bonds. So let's do these two examples. All right, in this first one, we have 1, 2, 3, 4, 5, 6. So this is a cyclo. And we're going to use hex, and because it has a double bond, we're going to call it hexene. So it doesn't really matter here if I count this as 1, 2 in purple or 1, 2 because there's nothing else to number here. We also don't have to say that. That is a given in the name. When you have cyclohexene, we know that the double bond is in positions 1 and 2. For this next one, it's not so obvious. So we know this is a cyclohexene for sure. So I'm going to go ahead and give that, man, my spelling today has just been atrocious. We're going to go ahead and give that the parent name. But now we have to worry about this group coming off. So I know that this is going to get positions 1 and 2. So my choice is to either count, and I'm going to count these 1, 2, 3, 4, 5, 6. Okay, that would give me a branch number of 6, or I can count the opposite direction starting here, 1, 2, 3. So you would choose in this situation to follow the blue numbering pattern because once you've taken care of your double bond, it's going to give your branch the lowest number possible. So the correct name of this would be 3-methyl cyclohexene. We won't see this situation come up much, but it is important to note because you may come across it in your textbook. So there is another rule that tells us if your substituent or your branch, your group, is on a carbon in the double bond, you must label that carbon carbon number 1. Okay? So in this situation, we see this methyl group is coming off of one of the carbons involved in the double bond. According to this rule, I must start numbering here. According to the last slide, I know that the double bond has to get carbons positions 1 and 2. I have no choice but to count in this direction because there is a branch on the carbon involved in the double bond. This might goof you up if you see it on homework or a quiz or a test, just because we know we can get a lower numbering system by counting it in the opposite direction, but that is not the correct way to do it. So we are dealing with cyclohexene. I'm going to go ahead and give us our parent name. We do not have to label the position of the double bond, but we do have to say what position both of our methyl groups are in. So for this example, because we had to start with carbon number 1 here and we had to count the second carbon in the double bond as being position number 2, we will label these 1,6 di, because we have 2 methyl groups, cyclohexene.